Hello again. All right, so this session is on the 96-board CEv2 specification. More of an introduction. I'm not going to go too deep. We have limited time. This is the hardware specification V2. Take that as a hint. And moving forward. So here it is. Here's the layout of the new spec. Yeah, of course, there's more than that to it. Right, so we'll go with a quick overview about 96 boards. 96 boards is an open platform specification and compliance. We work with members and partners to implement those specifications and compliance for single board computers, enterprise boards, and IoT and SOM now as well. We started because there was a lot of different interfaces and form factors for a lot of the new SBCs, and we wanted to standardize on that and provide a standard development platform, but also provide a set of choice in terms of SoC vendors and even within vendors SoC capabilities. And we've always taken a part to product approach. Our main goal is to make sure that people make their products on develop their products on our dev boards and then buy a bunch of SoCs from a vendor to sort of implement the final PCB for their product. So we are in the consumer enterprise IoT, TV, and networking market. We have SOMs, which are sort of less of a part the product to the silicon, more of implement a SOM, final design situation. And then we have mezzanines. Mezzanines are sort of what shields are for Arduinos. Mezzanines is for 96 boards, though they are extended PCBs which have different sensors, hardware of all sort that extend the functionality of your boards. Um, we have a few initiatives. We have 96 boards AI. These are a set of boards that are very specific to the AI ecosystem. We have 96 boards automotive, set of boards that are specific to the automotive market. Open Hours is a weekly call that I host. We talk a lot about 96 boards. It used to be live, but because I just ended up having more community interaction during that time, I ended up taking it offline, and we do chat a lot about what's going on within 96 boards. So I won't go too deep. Again, I see the clock ticking. I have a lot of slides good to go through this time. So again, what is 96 boards? We are a SOC independent open platform specification tailored for different market segment. Moving on. We want to achieve universal OS support. We are a SOC independent platform, and we thrive for rapid prototyping, and we want our boards to be used for eventual production. Um, so here are some of the platforms we've been working with. We work quite closely on the Android open source project or AOSP with Google. Um, we've had board supported in projects such as AGL, Unity VR. I did a demo with that early on. We have a lot of boards that are in Zephyr RTOS, which is supported by Zephyr RTOS as well. And we do support a bunch of stuff on Open Embedded. Dragon board has been big with Amazon Greengrass, AWS IoT, and other things. A few of our boards, such as the Poplar and a couple more, have been used as the Opti target boards as well. Um, all of our Dragon boards run open source GPU, so we've touched the Freedrino and Mesa space. So as you can see, we are involved in a bunch of projects, and they use our boards for developing and moving their projects forward. Right, let's go through all the specifications we have and the market segments we touch with those specifications. Today's CEv2 spec um, actually builds upon the original 96 boards consumer spec or consumer edition spec. These are low cost single board computers. They credit card sized, small, and compact, and they basically are used by open source community development for software, and they target mobile and maker market, and embedded anything that has a low power SoC that needs to run Linux. Enterprise is more of your networking and sort of server use case scenario where power consumption is not really an issue. Synquissa is a good example, and for networking, we have Oxalis board as well, which is a low power networking board, and Synquissa is the extreme opposite, where it's a high core count, high power board. Moving on to the IoT edition, these are low cost MCU based boards with even tinier footprints. They support Cortex A in some very rare cases, um, but mostly are for Cortex M and RSoC to run RTOS. I'd like to say almost all of our IoT boards are upstreamed in Zephyr, um, and they are a great target for development in RTOSes or any real time stuff you need to do. Um, and our latest addition is the SOM spec. These SOMs are designed with industrial use cases, so their connectors are such, and they guarantee dust resistant. So the connectors are water and dust resistant and vibration resistant, um, and they've been used. Funny to see Android things there, but yeah, so as I said in my last presentation, with the drone ecosystem, with our drone board, we are using the SOM spec, and one of the larger drivers for that decision was that the drone spec is actually has connectors that are rated for vibration. So yeah, rapid prototyping where you don't have to build a lot of the components right next to the APU. The SOM provides your power management, your memories, your storage, and you just have to extend the SOM in your final product. So it um, cuts the product time by a lot. So that's sort of an overview of the 96 board specification. um, Compliance is how we pass and fail a few boards, and it's basically comes down to the list I have: availability of documents. You need to send us board schematics and reference manuals and all of that stuff. All the binary blobs needs to be properly licensed and redistributable. You need to have hardware compliance with whatever spec you're using, and there is a small part of software compliance in the spec as well. You need to pass that as well. You need to have some OS running on it. You can't just send a board that doesn't boot, for example. And then we generate compliance reports and compliance services, and we get the boards. The 96 boards team gets the board, and we just test them to see that the claims are correct and the board's functional. At that point, it gets certified. All right, coming to the fun bit, Consumer Edition V2. The way this board came to be was a lot of talk with the 96 boards community about what they want to see new in the board, and that was mixed with what new interfaces SOC have realistically available, and what all we can extend on that area. So we did target. Now we have high bandwidth interfaces on modestly priced SOC as well. So like USB 3 is a commonplace, PCI is commonplace, high speed and high lane count CSI, DSI maybe interfaces are there as well. So that's what has gone into the consideration of the new spec. The entire spec is backwards compatible. We'll talk a bit more about that. So we are still targeting our AI, mixed reality, HMI, automotive, and 5G solutions, where a lot of data transfer, high speed data transfer from our external interfaces is required, whether it's cellular data, whether it's camera data, whether it's sensor data, or whether it's data coming out in like graphics or display. So as a result, we have new additions to the interfaces. We have dual lane PCIe on the new high-speed 2 header for 5G modems or storage. We have Ethernet as part of both CE and CE extended designs on board, which is a big requirement that we saw. We have multiple new camera and display interfaces. Those are mixed on the new high speed header 2. Those are mux, so you can have high speed DSI or high speed MIPI, DS, LVDS, or embedded display port. And one of the more important things that everyone loved to see was an onboard USB UART header, an onboard USB UART micro USB. People were just sort of bored of the UART mezzanine, I guess. So they didn't like that. So we removed the need for a UART mezzanine. We have onboard debugging board. And the new low speed header 2 has CAN bus and analog audio. And as I said, I think I've already mentioned what all the new high speed header 2 has, and fully backwards compatible with V1. So these are the new boards. On the top, you have the TB96A IoT 1126CE. This is sort of the minimalist implementation of the CEv2 spec. I'll get into the detail about that in a bit with the video, and I'll show what the boards actually look like. And the one at the bottom is the CE extended, and so that's the CE extended form factor. Again, I'll go into the detail. That this is the full featured implementation of the CEv2 spec. All right, moving on. Yeah, so our first board is powered by a low power Cortex A7 CPU, the RV1126. It has basic graphics acceleration, but it's mainly for video encoding and decoding from a camera, so an IoT, IP cam kind of situation, or thereabouts. So a low power with an inbuilt NPU to do basic image recognition on camera, and has all your regular connections, including oops, where did that go? Including an onboard Ethernet port, which we managed to put and um, not go against the spec with the height restrictions. So you can still put on your mezzanines and you have a full fat Ethernet on there. This one's a bit more powerful. It's based on the newly released RK3568. So it's Cortex A55, and if I'm correct, that's ARM v8.2. Well, I know a lot of people are actually want to see ARM v8.0 disappear. So there you go, a new board with ARM v8.2. It has a Mali G52 GPU. Technically, that's compatible with Panfrost, and eventually we'll like to implement that. It has 2 gigs of RAM and NPU on board, and we have dual gigabit Ethernet on this one, um, just to show how much we can extend that, and your regular wireless interfaces. All right, so I have 10 minutes to go. Let's see how quickly I can show you guys this video, and I'll probably like try and skip through a lot of them, a lot of the bits of it. So these boards, as you can see in front of me, the let's go to the regular CEv2 spec board. So when I say this is a minimalist implementation, is because this board only has the one high-speed header, does not have a second high-speed 2 header, and not all boards not all SoCs have a bunch of that, high-speed interface, including a lot of PCI lanes and extra DSI lanes. So that is optional, but you still have the LS2 connector on there, and you have the Ethernet jack. The Ethernet port, the RJ45 port is a must. The onboard UART to USB bridge is a must. So that can be end up in micro USB or Type C. The way is fine. So those two inclusions are compulsory, and the rest remains the same. Um, so with the Ethernet implementation, we were actually able to remove the height restriction, and so it's actually compatible with regular 96 boards mezzanine. Um, and I'll show that working in a second as well. This is more of a full featured board. We have both the high-speed 2 headers fully populated and the low-speed header as well. And one of the things that we needed to do there is to move the SoC towards the back side of the CE extended spec. Not to say that it's not possible on the regular CE board. We have seen a lot of boards in the past, a lot of 96 boards in the past that have had the sock at the bottom, and that's how we envision the spec V2 being implemented on a regular CE V2 form factor instead of the CE extended. But this time around, we had a bunch of board space, so the sock was just simply moved towards the back of the board, which gave us a bunch of area at the bottom side of the board to have fun things like PCIe slots for SSDs and modems. One more quick change on the power side of things that I'm just pointing out is that our power connector has changed on the CE extended board to be a larger barrel jack. I think it's the 5.1 mm1, the same one Arduino and a lot of other boards use. And the reason is just availability. People have a hard time finding the smaller barrel jack. So we just changed the spec for the larger board since the height restriction is not an issue on the CE extended. On the older CE board, the height restriction is an issue, so we decided to stick with the older barrel jack as well. Apart from that, I don't think I have a whole lot to demo here. So I think I will close out the video with that. Um, let's see if we have any other questions. Right. So Arn has a good question, and this was discussed earlier. Um, so it depends on the implementation now. Um, right now, I don't think this board has that. But eventually, what we were discussing on doing a new V2.1 rev was the possibility to sort of add, instead of just a simple bridge, uh, Cortex M0 based MCU in there, so you can do a micro BMC kind of situation. But then the whole silicon shortage thing with the MCUs happened, and we decided to hold off of that. So eventually, what I'm working on on the side is to put the entire spec on as a restructured text thing similar to what ebbr does. And once that goes live, you'll be able to make suggestions as maybe even as a PR onto the spec, and we can revise the spec like that. And this was one of the first things that we wanted to change, and also have sort of a standardized way to do it. We don't just want everyone going and implementing their own type of micro BMC. So I'm kind of I'll say that's reserved for V2.1. And if you have any standards in mind for micro BMC that you've seen other folks use, feel free to contact me, and I'll open a discussion on that. And Let's see if there are any questions that come along. Anyone can submit a PR or only the members? That's a good question. Um, I think we'd like anyone to submit a PR, and if it's sensible, then it will be discussed, and members can come and reject that. But um, but yeah, we'd like to be have it open. Whether it makes to the spec, then that's a decision for the members to take or for the steering committee to take. So I guess that's for once the repository is released. Do you find any issues for Panfrost support versus traditional DDK for the GPU? Depends on the GPU itself. Right. So Panfrost isn't perfect. In some scenarios, the traditional DDK will have better performance, and but it's sometimes because Panfrost is open and Panfrost is so closely tied to the rest of the Linux community that when the OS takes over, um, it doesn't really interact well with the when a traditional Linux takes over, it doesn't really interact well with the closed source Mali stuff, because that's geared towards Android. So for Android, maybe DDK has a better place, but in my experience, when I've worked with Panfrost versus Mali binaries on sort of a more generic Linux platform, um, without with running upstream kernel, it's better to just run Panfrost. So, unexpected question from Martin. Yes, there is a recommendation for SPI Flash for onboard memory. eMMC, a form of memory will always be on board, eMMC or NAND or at a minimum SPI, but there is a recommendation for separate SPI for onboard firmware storage. But on that firmware storage, you might want to hold your thoughts for the next few months. 96Boards might have something new to announce in the coming months. That's all I can say for the time being. As far as the hardware spec is concerned, we don't force SPI flash for the time being. All right, just 1 minute left. So let's see if there are any more questions. All right, looks like we are at the top of the session. So thank you so much for um, attending. And I don't see any more questions coming in. So I think this is time to close out. Thank you, everyone. And I hope to see you soon. And yeah, you can always contact me at sahaj.surup@linar.org. Email would be on the slides and in the presentation as well. So thank you.